installment of the Aliyah Virtual Annual Meeting. Our topic today is Life Cycle Assessment of an Efficient Hydraulic Fluid. Our presenter is Ben Tan. Ben is Technical Director for Asia Pacific of Evonik Oil Additives. Before I introduce Ben, I'd like to bring your attention to the sponsor of this webinar, the Asian Lubricants Industry Association. Aliyah, which is based in Singapore, represents the entire lubricants value chain in the region. And this webinar is just one of the benefits that you get as an Aliyah member. Finally, I'd like to introduce to you our speaker today, Ben Tan. I've known Ben for many years. Ben is the Technical Director for Asia Pacific region at Evonik Oil Additives. He started his career with Evonik in 2007, working in the Process Technology Group and directly responsible for the product manufacturing processes of the plant located in Jurong Island, Singapore. Thereafter, he moved over to the technical service role, working side by side with the entire customer relations team located in Singapore. In 2018, Ben was promoted to the current position that he's holding now, which is Technical Director for Asia Pacific region of the Oil Additives business for Evonik. He's responsible for overseeing the entire technical team in Asia. Ben has a degree in chemistry and a doctorate from the National University of Singapore. Welcome to the Aliyah Virtual Annual Meeting, Ben.
Okay, good afternoon. Thank you very much, Vicky, for the kind introductions about myself. So, and also very good afternoon to all participants who join online. So I'm going to start sharing my presentation. Yep. Okay. So once again, very good afternoon. And the topic I'm going to deliver today is on the life cycle assessment about a efficient hydraulic fluid. So what does it encompass? So when we talk about this life cycle assessment, so no doubt in this entire presentation, we're going to go through many times about this word that's going to appear many times called sustainability or sustainable. And the Brundtland Commissions, in 1987, published their first volume of report called Our Common Future. And in there, they define the word sustainable development. Sustainable development is development that meets the needs of the present without compromising the ability of our future generations to meet their own needs. Okay, I'm trying to also find the pointer. Yeah, sorry. So moving on next to this slide. The concept about sustainability is basically composed of three main pillars. So what are they? They are the economics, the environmental, and also the social. But in a other way of defining it, we can also call it the profit, the planet, and also the people. All right. So there has been people out there, or probably even organizations, that thinks that the planet, the people, and also we call the profit, they cannot coexist. So it is either you have profits for your organizations, or you take the other route to have a more sustainable planet. Yeah. So this is actually a very common misconception. Okay. So, but however, for the last many years, so or a couple of years, so this misconception is slowly starting to change. Yep. So that means how people view it are also changing. So we are much more looking now at an integrated system. So how to integrate the profit, the people, and the planet all together. Okay. And the efforts from organizations, from companies, or even associations, who are taking, putting all the support towards this sustainable development of the people and also our planet, they're actually bringing significant profit eventually. So this system is basically based on the understanding and the needs, and it has to be quantified. So this is how it should be. And the answer to how these three pillars can basically coexist again, yep, is to quantify is by doing the quantification of an organization's product or the service through a process called the life cycle assessment. And this is about what I'm going to talk about today. So the life cycle assessment is actually a ISO 14040 series of standards, and it is used to address in a quantitative way, yep, through these assessment methods, on how it can have it impact towards the environmental as a result of the product or the service, throughout the entire life cycles. So basically, in short, this LCA, it is a methodology used to assess environmental impacts associated to all the stages of the life cycle of a commercial product or a service. Moving on next. So I would like to talk about the life cycle thinking. Okay. So when we talk about life cycle thinking, so it goes very well beyond just talking about the market price of a product, talking about the quantities or even the product specifications. Yeah. So not only that, it is actually a much more comprehensive product characterizations. And it goes all the way from the raw materials that is being used to make it, and then all the way to the product's end of life. So we can compare all the various process routes, yep, for the same product, or compare alternative products with the same benefit that it brings to the customer eventually. So one important aspect of this LCA, I would say, is that it can actually expose what are the weak spots and indicate what are the potential areas for improvement in order to bring future or further developments to better a product or to come up with even more higher performing products. So that means this approach is not only looking at the usage of the product or the benefits the product brings as of today and in a certain specific application, but it also led to how the innovation cycle and also the development of a newer products into the future. Okay. And in the next slide here, what I have here is to help you look at the different terminologies in order to better understand the different steps in the life cycle assessments. And here I'm using example of a typical process change of a production and also the use of a material. When we only look at the production itself, okay, so these steps is called the gate to gate in a life cycle assessment. So as we move on to include the material supply as well, and then to the production of the product. So this will be called the cradle to gate step. And if we look even further to the downstream of the products includes the use phase as well as the end of life of a product, or you can even simply call it the disposal stage. So we will call this the cradle to grave. Okay. And when there's a possibility to also look at recycling the product when it reaches the end of life, or to reuse it again as a raw material to make the next batch of product. So this will be a complete cycle in the LCA, and it will be called the cradle to cradle step. So again, this LCA is basically an ISO 14040 series of standards. Okay, and it means that from all the way from the raw materials acquisition stage or generation from the natural resources itself to the final disposal stage of the product. So in a LCA, so various potential environmental impacts are being analyzed, and I will come back to this later when we touch more on this. Yeah. So the next things I want to just run through quickly with you is on the life cycle assessment. So how to do it, yeah, basically. So the life cycle assessment, or this, according to this ISO 14040, so it comprises of 4 steps. So the very important first step is the goal and the scope definition. So the context of the study has to be first defined. Yeah. And what does that mean? So it means that we define the system boundaries. So for example, do we want to take into consideration the entire value chain of the product, or is it sufficient to just solely focusing on the cradle to gate perspective? Yep. So these are the very initial definition, and the goals or scope that needs to be identified. And then the functional units. So the functional units is important because it is a basis where it's used to do all the calculation and to be referred to compared to certain systems. And I'll come to that, in the next couple of slides after this. And finally, this will be followed by the life cycles inventory analysis. Okay. And what happens here? So in the LCI, life cycle inventory analysis, so it basically quantify the inputs as well as the outputs that we are going to assess. Okay. And then after that, then we move on to the life cycle impact assessment. Okay. So, and then here we try to get understanding on the impact of the materials and also the energy flows on the environmental systems. So these two, life cycle inventory and life cycle impact assessment, are much more objective because it's something that can be quantified. And finally, the life cycle assessment exercise, ends with this interpretation. So the life cycle interpretation. So over here is much more on drawing the conclusion based on the life cycle inventory and the impact assessment, and then make recommendations, yeah, accordingly. Yeah. So so there are many different impacts, that can be characterized because they falls into various different categories. So for example, the global warming potentials, the acidification potentials of the seawater, etc., etc. So it's important, again, what categories, you want to define these, right at the beginning. Okay. So moving on, next. Here, actually, this slide is to help you to better visualize. So what it really means by life cycle inventory analysis. So LCI is actually one part of the LCA phase, okay? And it basically involves the compilation and also the quantification of various environmental inputs as well as the outputs. So in order to make a product, for example, in the processes, as shown here in this diagram. So you have inputs of raw materials, you have outputs that's coming out of the process as well. Okay, so all this, it requires, it allows a certain quantification of the elements. Yeah, like I said earlier, whether is it energy or is it the emission. Yeah, and this flow diagram, as shown here, the process flow diagram, is to help you to visualize that we need to first define the system boundary. So what has to be included? And if you still recall, I mentioned earlier the cradle to gate. Yeah. So this will be from raw materials all the way to the products finished being manufactured. So this is called the cradle to gate. Yeah. Then we developed, what are the data collections methods? Yeah. Before we finally execute the relevant inputs and also the outputs data collections. So like the electricity is being used to produce the products and the thermal energy, and then what are the direct emissions into air, into water or soil, as a result of the product that's being made. So when it comes to this slide, so basically it's just to give you a better, even deeper understanding about what we are talking about, inputs and the outputs data. So inputs are the raw materials, for example, and then what are the primary raw materials that could be used, and then whether the raw materials are using some kind of renewables raw materials like palm oil because they are renewable, and then this should be the main raw materials. Yeah. And then what are the auxiliary materials that could be also used as part of the additives to make your product or to make a product. In order to enhance a product, maybe a certain characteristics to make it more sellable, but it does play a minor role, in terms of the comparison to the main raw materials. And finally, the utilities, including thermal, electrical energy, compressed air, cooling water, and many, many more. Yeah. So then on the output side is about the product itself, obviously. So what are the valuables outputs coming from the products or the goods or the service that's being offered? And then what are the potential side products they may be churned out during this process of making the products? Okay. And then during the process, sometimes there will also potentially some surplus of energy that's being generated. And finally, also potentially the non-valuable outputs, such as the waste that is being generated or emissions, going into the environment. Okay. All right. Then to take things a step further, so basically at looking at this impact assessment, so there are actually many different methodologies out there that can be used. But over here at Evonik, so we look at these things called the midpoint categories. As you can see here, I have a list of what are the categories. Yep. So out of any life cycle assessment, so you achieve result that shows you impact on the, for example, the human toxicity, yep, or ozone depletion, or climate change, or land use impacts, yep. So but these are somewhat, to certain people, they find that it's difficult to interpret. So there are other also methods or methodologies that is to look at the damage categories. So what damage it causes to human health, what damage it can potentially cause to the natural environment, or the natural resources. Yep. So they are quite different. So experts in the community, they are working diligently to develop this methodology, and they're trying to link them together, the midpoint categories and the damage categories. So at the moment, I would say this is still a work in progress. So, but it will develop over time. So LCA will become more and more objective in the future, and less subjective. So, but until then, yeah, it is very important that when we do a LCA, so we need to first again define the system boundaries. Yeah, that's very important right at the beginning, and in order why to ensure that the comparison that we do eventually is quantifiable. Okay. And to do that in a more practical sense, so let us take a look at examples. And here we will look at a midpoint category called the climate change. Yep. And this will be related to the subsequent slides that I'm going to talk about. Yep, coming up. But before we do that, so I mentioned about this term functional units earlier. So it's actually a quite important terms, because these functional units, yep, is something that will be used to refer to make calculations. So again, it is a measure of the performance, yep, on the functional outputs of the product system. Yep. So it provides, as a reference. So if you don't choose the functional units, well, then the outcome of the LCA results may not be uh, comparable enough or quantifiable enough. Okay. So in this example that I will deliver today, so the functional units, yeah, is a hydraulic system, fluid system of a mid-sized excavator, and we are talking about one typical oil drain interval of 2,000 hours. Okay, so this mid-sized excavator basically uses about 260 liters of hydraulic fluid. And in the system here, we have the monograde hydraulic fluids, and then a multi-grade but shear stable, yep, hydraulic fluids. So this monograde hydraulic fluid system, so it contains a standard anti-wear package and the mineral base oil. Whereas the multi-grade shear stable hydraulic fluid, apart from having the standard anti-wear package and the mineral base oil, it also consists of a certain percentage of shear stable viscosity modifiers. As a result of this, yeah, and we went on to do trials, yeah, in the field. So the monograde hydraulic fluid resulted in an average diesel consumption or use of about 24 liters per hour work. And for the case of the multi-grade shear stable hydraulic fluids, so the diesel use is 21.5 liters per hour. So there's an obvious reductions in terms of the amount of diesel being used. So here again, by using these exact same functional units, yeah, so the comparability of the LCA results, yeah, are going to be ensured, yeah. So, but before we look into that results yet, so how does the mechanism work? So I'm sure some of you might have already seen this slide multiple times. Yeah. So on this log viscosity versus the log temperatures graph, so there are actually two very prominent lines. So one is the gray, light gray color line, and one is the purple color line. So it represents the monograde and then the multigrade shear stable fluid. Okay. So the multigrade shear stable fluid has a much flatter line. Yep. Very well due to the higher VI effect. And what it does is that it actually allows a wider extension of the whole temperature window. This is the temperature scale for both the low temperature site and the high temperature site. Yeah, in comparison to the monograde. And then, but what does it bring? Out of this widening window. So it actually helps improve the hydromechanical efficiency at low temperatures, but on the other hand, also improve the volumetric efficiency at the higher temperature side of it. Okay, so by doing so, this multigrade fluid actually led to a improve in terms of the overall hydraulic pump system efficiency. So the trial that has been done, or we call it the performance demonstrations, so will carry out, throughout various years, in probably in the last 10 years, yeah, at Evonik. So we look at, different types of excavators from various OEMs, yeah, and then there's also a certain a specific phases of the test that we have to do. For example, truck loadings, digging work, traveling, idling. Yeah. And then there are certain parameters that has to be considered in terms of the variations, like the operators, and then how the engine runs at 100% or 70%, and the initial oil temperatures, the starting oil temperatures, and then the bucket size that is being used. Yep. So all these are taken into careful consideration. And not only that, so during the oil change from one oil to the next oil candidate, yep. So we also ensure that these are done properly, so that in order to make sure that the results eventually that is gained, the data collected are representative and significant and make, are confident to be used. Yep. Okay, let's have a look now in the next slide here. So this is the result of the life cycle assessment for the monograde hydraulic fluid. Yep. So on the right hand side here, you have the value of 238. Yep. Kilogram CO2 equivalent emitted, yeah, per cycle. So what is this? This is actually the CO2 emissions from the production of these monograde hydraulic fluids that is used in that trial. And then next, in the trial, we also use diesel, yeah, so that the excavator can operate. So the production of the diesel will also generate a certain amount of CO2. And so these are also taken into considerations. Yeah. And then eventually during the excavator operations, so it consumes and burns fuel, diesel, sorry, and this generates a huge chunk of the CO2 emissions. So in total, it generates about 148,000 500 kg of CO2 equivalents, yep, throughout these whole operations using the monograde hydraulic fluids. And in the case of the multigrade hydraulic fluid here, so we are talking about almost about the same amount of these CO2 emissions from the hydraulic fluids itself is 260. And then the diesel uh, used, so the emission to produce them is about 18,000. And then the diesel consumed during the excavator operation is about 114,000. So this is quite a reduction compared to the earlier monograde results that you saw. And in total, it leads to about 132,000 or 133,000 kg of a CO2 equivalents emitted, yeah, per cycle. So we're talking, okay, then here, they could be, very good exceptional cases. They could be, some less than average cases. So we should not be taking, the best of the whole entire trials over the years. So what we did was actually take an average case. So it's about, let's say, 10% savings in terms, yeah, of the CO2 emissions or reductions. So comparing them side by side, yeah. So what you see here is that again, this 238 kg CO2 is the carbon footprint of the monograde hydraulic fluid itself. And this 260 is actually the carbon footprint of the multi-grade hydraulic fluid. All right. Okay. So the reductions, yep, coming from the use of these multi-grade hydraulic fluids is about, let's say, 10%. So of this is about 14,800. So if you compare this number 260 or 238 to the 14,850, so it's actually in terms of magnitude is almost like insignificant or less significant, maybe. Yep, I should use the word less significant. So but um, a very important thing I want to highlight is that some some of them out there actually they thought, okay, since the number is so small in terms of magnitude, maybe let us just neglect the carbon footprint of the product itself, and let's talk more about these reductions or potentials of these emissions. Yeah, 14,800, and this 14,850 reductions is a term that I need to explain to you later. Is called avoided emissions. That means as a result of using this multi-grade, so you could have avoided about 14,800 kg of CO2 emission into the environment. Yep. So it's again back to this. So to think that we can neglect the carbon footprint due to the smaller magnitude in comparison to the avoided emissions, so it's actually very dangerous to think it that way. Yeah. Why? Because we all, as a part of the industry player, so even though we invent and supply high performing products, yeah, to the market, it can bring great benefits. It can bring big potentials, like in the case how it can help bring the avoided emissions. Yeah, but it's also important that we need to do our own homework. So we need to continuously work and look at how we can potentially reduce our product carbon footprint. Yeah. So it's not only about how our products can help others, but about how we can also do something to reduce, the carbon footprint emitted during our product making. Right. So now we move on to this avoided emissions topic. Um, so let me try to explain a little bit. Yeah. So avoided emissions are actually the emission reductions that occur outside. So outside of a product life cycle. So you saw earlier a product life cycle starts with the raw material, and then the production, and then the use phase, and then finally the disposal. So these are occurring outside of the product life cycle. So meaning, so as a result of this product, it potentially leads to a certain CO2 emission reductions. Yep. So the example that I used today in this presentation earlier where comparing the multi-grade shear stable hydraulic fluid is one of them. But to help you expand your visualization, I give you another example. Just today, we are all attending this webinar, but in the usual days, pre-pandemic, most of us would be sitting in the conference room together. Yeah. But now we are all doing teleconferencing. So with teleconferencing, so the potential avoided emissions are coming from all the non travels because we are not traveling, so we do not potentially cause more CO2 emissions into the environment. So these are called avoided emissions. Okay. So the question next is that why should we be looking at avoided emissions? It is important because it can showcase how advanced lubricants can basically help to bring positive impacts or benefit, and how they can support everyone, or basically the community towards a low carbon economy. All right. And in order to showcase this, so we need to include the use phase of any lubricant formulations that we are looking at. Yep. And therefore, the overall view of the entire formulation or a product or a service by comparing, the whole cradle to grave life cycle assessment, so is important. So again, this will help us to quantify and report eventually what are the potential avoided emissions. Yep. And there are also uh, another important points to consider when we do such a comparison. So here I want to emphasize again. So the avoided emissions coming from such a system, so it can actually be a term also as what we call handprint. And in some other this resource, you may see them as scope 4. So there's scope 1, 2, 3, and 4. So actually, this avoided emissions is more like a handprint. So I tend to use this word handprint because it's clearer and easier to understand. Okay. So the second bullet point here is that so these avoided emissions that was defined as a result of using a certain product, yeah, but it must not be subtracted. So it should not be subtracted from that means from our own product carbon footprint, yeah, because to do that is actually not right because it's completely a different system. Again, we are comparing, okay, and the avoided emissions usually also includes a moving average. It's not something that's fixed because as time goes by, things change, and so the life cycle assessment of a product of or a certain product may need to be repeated. And as a good practice, it has to be looked at on a more regular basis, just in order to ensure that it always stays representative. Yep. The solutions that we are comparing also has to be sensible in terms of the environment, these industry averages. So, for example, the hydraulics fluids case that I showed earlier, we took 10% as the average. So if we have a case of let's say 18% and we just use that, so it might not be so sensible because the comparison may not be relevant eventually. Yeah. So, and finally, the last bullet point is also about a question that always come across or appears when people talk about avoided emissions. So, who is the owner of avoided emissions, basically? Yeah. So, very thankfully to the guideline that is available, that has been put together by International Council of Chemical Association (ICCA), as well as the World Business Council for Sustainable Development (WBCSD). So, in this, the essential role of chemicals. So there are guidelines about basically it gives you some solutions to do comparisons. So it explains to you what are functional units and how calculation methodologies can be applied, and then the contributions of different value chain partners throughout the whole comparison. So these are publicly available, so it can be easily downloaded from the ICCA website. Yep. And there are also 17 different case studies in there, and from all the various different companies. Yep. Um, next, next here, what I have is that let's have a look. On the right hand side here, what I have is that is an example of the communication on the value chain of avoided emissions by different individual partners in the whole value chain. Yep, basically. So, for example, there could be several different raw material suppliers in order to make the product. But not every raw materials are the main raw materials. If you still remember, I mentioned earlier. So some could be just to enhance a certain properties, but there is definitely one material which is the main one. And then it comes to the chemical companies. So the chemical companies that make the products, and it goes into the process, and then the end products being manufactured. And then there's also the service providers who actually help to service between the manufacturers and also the end users. Yep. So the end user or the technology users, and then eventually the products leading to the disposal or end of life. So they are actually color coded, by blue, light green, and dark level of explanation. For example, the blue color, it says a company shall not claim the value chain avoided emissions. So they are not allowed to claim. So then who are allowed to claim the avoided emissions? So basically, there's only the technology user. So the technology users are the ones that can claim these avoided emissions. Okay. And then on the left hand side here, what I have is a table that shows the significance of the contributions of chemical products uh, into the value chains of avoided emissions. And it is basically entirely based on functionality approach. Yep. And these significance are categorized by various category. For example, fundamental, extensive, substantial, minor, or is it too small significance of a contributions to claim? Okay, so so depending, yep. And I just take one example here, extensive, yeah, to elaborate a little bit. So for example, if a chemical product is being part of the key components, I mean the key raw materials, yep, and the property of these functions, they are very critical or very essentials in order to help enable, to help bring positive impacts towards the emissions, yep, into environment. Then this will mean that it has extensive significance of contributions. Yep. And this is where you see all these on again on the left right hand side. So whether is it extensive, is it substantial, minor, or too small, in terms of the contribution of the different chemical companies towards making of the products in the whole entire value chain partners. All right. So, so with that, my slide is not moving. Okay. So with that, I've come to the conclusion slides now. So to conclude my presentation, uh, we were able basically to show that the tool of the life cycle assessment is actually very good and can be used to demonstrate that certain high performance lubricants they show environmental benefits during the use phase, which it will not be included if we only look at the life cycle assessment from cradle to gate viewpoint. So here again, the focus is that we should look at the full life cycle of a product. So entirely, yep, from cradle to grave, yep. And then one of the other key emphasis I have here is on the critical elements, so that the boundary conditions or whatever assumptions or whatever averages that we are going to use as part of the the whole uh, unit for the life cycle analysis being used. Yep. So it has to be something that is of comparable, so that eventually when the life cycles assessment is complete for the product, so it can be something that is credibly communicated and claimed. Yep. So in all, so the things does not just stop after the life cycle assessment. So the main questions is that what do we use these results for next? Yeah. So this is summarized basically in the final bullet point here I have. So we can actually use this data to really drive the portfolio management, yeah, of our product, at the same time also drive our innovation efforts, so that we ensure that we together, as a lubricant industry player, so we really push the boundary, limits, and then we showcase that our solutions can provide significant positive impacts on the sustainability journey that we are all embarking on together. Yeah. So I would say then the final sentence that this is really a great opportunity
Oh,
for all of us, only if we embrace assessment into our processes or our. That's all for my presentation today. And once again, thank you very much for your attention. And yeah, I'll be glad if there will be a couple of questions. Yeah, for me. Thanks.
All right. Thanks very much, Ben.
Yeah.
So
Yeah.
far, probably our attendees are still warming up. So I have a
Mm-hmm.
question. This is a personal question. So assuming I am an end user or I am considered as the technology user, is that correct? Let's say
Mm-hmm.
let's say I'm the one using your the lubricant, the hydraulic fluid. Let's say I want to embark
Yep.
in doing the ISO 14040 uh,
Mm.
with the application and the products that I use in my operation. Um,
Mm-hmm.
is it straightforward to do that? Meaning, do I need to be certified by a certain body in order to do a proper
Mm-hmm.
LCA analysis using this ISO standard? Or is this something that we can just carry out, and then we need probably a third party to sort of review and assess if the
Mm-hmm.
calculations or methodology was done accurately
Mm-hmm.
according to the said standard?
Mm-hmm.
Thank you.
Okay, good. I think that's a very good and valid question. So, these ISO standards, there is a very clear guidelines, what you should do and what you could do. So, if you basically, follow strictly according to these guidelines, as they mention in the document, so you could actually do it on your own. But the other part about certification is only if you requires, or some, it means when you want to do this 14,040 for your product, for example, and then in your customer request for that kind of certification, just to prove that the things that you do is right, then you need to go for that. Otherwise, then you can just claim that you're following these ISO 14040 standards, and this is how you do your product carbon footprint. Yeah, basically, or the life cycle assessment. Yeah. So I hope that answer your questions, May.
Yes, sorry, I was on mute. Yes, thanks, Ben.
Okay.
Maybe
Yeah.
I
Okay.
can ask again the attendees for some questions. But a few comments from the work that you did on the hydraulic fluid. I saw it
Mm.
probably highlights the sustainability aspect if you are using a high performance hydraulic fluid, isn't it? Because the savings that were generated were basically because you had less diesel fuel use, isn't it? So I think this is a
Mm-hmm.
really good
Yep.
marketing scheme as well, but which is it's technically supported also to show that it
Mm-hmm.
does matter when you use high performance lubricants in your system. Yeah. Okay.
Mm-hmm.
Right.
Mm-hmm. Yep.
Any other questions from anyone? Okay, they're very quiet. You talked about handprint, isn't it, Ben?
Yes.
What's the difference
Mm.
between handprint and footprint? Because in the past, you always see carbon footprint, isn't it? So, what is the difference?
Yep.
Thank you.
Okay, sure. So let me try to explain that. It is not so easy to understand if people are listening this for the first time. Yeah, on this footprint maybe is quite common, but handprint, is not so common as to certain group of people who are not so much exposed about this. Talking about environmental emissions. Yeah. So, but I have to explain both. Yeah. So, carbon footprint basically is the emissions that is being generated as a product is being made or manufactured. And this basically again covers from the cradle to gate steps in the life cycle assessment. Yeah. So if we use in a simple language, so basically the carbon footprint is a combination of all the negative, sorry to use that term, the negative impacts of one's actions. That means, to manufacture it is the action has on the environment. But on the contrary, carbon handprint is all about the positive environmental impacts that a product or a service that can potentially bring, towards the environment when it's being used throughout its life cycle. So that's the definition. Yeah.
Yep, that's really good. The positive, and the not so positive side. Yep, that's really good.
Yes. Yeah. But of course, may when we want to apply this handprint, carbon handprint, that means we want to make some positive impact. First, you need to have a product. So again, in order to make a product, definitely somewhat, yeah. So we cannot avoid creating emission. So again, back to what I mentioned earlier, as a responsible industry player, so we should also look at how to reduce our own product carbon footprint. So that's why I say it's very important, the both the carbon footprint and then the carbon handprint. So both are equally important actually. Yeah.
Right, thank you. Miss Vicky, do you have a
You're
question
welcome.
for Ben?
Yeah, I just have a quick question, Ben. So LCA has been
Mm.
around forever, at least as far as I can remember. But are your customers requiring you to provide an LCA, for example, for an additive package that you're selling them, or for example, perhaps just the 4-point depressant, or is that a requirement now to do business, to sell a product?
Uh, okay, I would say yeah, thanks. I think that's again another very good question. So I'll say right at this moment, so we are all still at the very initial starting phase, talking about emissions. I know this emission topic has been there for decades, but in the recent years, yeah, that means a short, a few years, yeah, back. So people are really seriously, organizations, companies are really putting in a lot of seriousness looking into all this. So then these life cycle assessments are being looked at, and it has to be looked at, product by product. So to answer your questions, whether customers are asking for it at the moment, so far, for Evonik's case, oil additives, no, yeah. But I don't rule out the possibility that they will come and ask us for this, in the coming years. Yeah. So that means we have to prepare ourselves for this so that we are not left behind. And as the industry move on, customer move on, we also move along, and then we will be able to catch up with their demand or their interest. Yeah.
I guess a subsequent question to that is, do you voluntarily provide an LCA for every product that you sell today?
We don't, yeah, at the moment. Yeah.
Thank you, Ben.
Yeah, and why sorry, and why we don't is because customers are basically, not every customers are asking for it. Yeah. So only customers who are also looking at this, then we have to provide that to them. Yeah.
Not yet, Ben. It will come.
Yeah, that's right. So everything will evolve, with time. So yeah.
All right. Last call for any more questions for Ben. If not, I
Mhm.
think that was really good. I think it gives us a better overview of LCA as well as the ISO methodology, which is good because in the past we didn't have this standard. So a proper guidance is definitely makes our lives much easier. Yep. All right. Thanks very much,
Mhm.
Ben,
All
again.
right.
And now we go to our upcoming events. So again, we would
Mhm.
like to invite everyone. We have three events coming up soon. One is mitigating degradation and varnish in industrial lubricants. This will be done by Fluidtech, by Lars and Joe. So again, although this is not directly impacting sustainability, but if you see, if you have less downtime, it means your equipment are more efficient, then it also saves money, and also of course in terms of the uh, uh, sustainability aspect, it also helps. Yeah. And then we have a white paper. I'm sure you've all heard about the white paper we did last month. This was on anti-counterfeiting in the Asian region. This time around, it will be on the commercial vehicle lubricants. So we will look at 4 countries here in Southeast Asia and try to understand on the disparity on the use of the required lubricant versus those that are actually being used. And at the same time, look at the possible impact it can cause or damage if you don't use the prescribed lubricant. Yeah, so that's very interesting. And then lastly, this is going to be done by Rajesh Mushni, one of Munshi, sorry, which is one of our an expert in metalworking fluids. This time around, we will look at the common field issues, so real problems that we see in the market, and some recommendations on actually how to troubleshoot these field issues that we see. Yeah. So again, please do go to our website so that you can see there these events, and then register as early as you can. Once you register, we will be sharing with you a link which you will be using to join the webinars. All right. Again, thanks very much everyone for joining this session, and thanks so much Ben for sharing your knowledge. Until the next time, have a good day everyone. Bye bye.
Thank you. Bye bye.